All right, this is now our last lesson for lesson 2. So this is the end of our strong acids and bases, and then next class we are going to do weak acids and bases. So in this lesson, what we're going to do is we are going to calculate moles of acid needed to reach a desired pH. So we're going to go backwards. In these questions we did above, we found pH from given concentrations, and now it's like we're going to be going from the given pH or POH back to the concentrations or mass or moles or whatever it is they ask us for. Now, this is the one that always gets me, because you're going to always convert the given pH, right? So they're going to say at a pH of this. You're going to convert that given pH to the ion that was produced in excess. So if you have an acidic solution where your pH is less than 7, you're going to start with an excess hydrogen ions from the pH, and the excess hydrogen is going to equal the hydrogen ions and the hydroxide ions, like the difference between them, in the original concentrations. If it's a basic solution, so if they start with a pH that's greater than 7, then you have an excess amount of hydroxide, and you're going to get that from POH. So even if they give you pH, you're going to have to convert to POH to find the amount of hydroxide in excess. And then the amount of hydroxide in excess will be the amount of hydroxide minus the amount of hydrogen ions in solution. So let's look at one in practice. This question says, how many moles of sodium hydroxide was added to a solution, a 40 milliliter solution containing 0.18 moles per liter, or molar hydrochloric acid. So we know the original concentration of the acid, but we want to know the original concentration of the base. But we're going to produce a solution with a pH of 1.5. When we have a solution that has a pH of 1.5, this is very acidic, which means that the hydrogen ions are going to be in excess. And that is going to be our first job to find. So again, it's kind of, if you practice enough of these ones we did before, so when we have a pH that is less than 7, something like the first one we did, or I guess not the first one we did. Anyway, if we had one where the pH was less than 7, then we would be finding the hydrogen ions in excess. And then if we have a basic solution, we are finding the hydroxide ion in excess. And again, that's just sort of the whole gist of it. I was panicking, so I was like, didn't we do one with hydrogen ions in excess? I only did 2 with hydroxide ions in excess. I had to scroll back a little bit. One more. Here we go. So this was my pH less than 7. So we had the hydrogen ions in excess. So again, we're doing these questions in reverse. pH less than 7, find hydrogen ions in excess, so that then you can find whatever one is missing. If you have a pH greater than 7, something like this one, you have to go to POH to then find the hydroxide ion in excess, so then you can find the original concentration of your species. There we go. I was doubting myself there for a second. Okay, so this solution has a pH less than 7, so it's acidic. So we're going to have hydrogen ions in excess. So from pH, you're going to find the hydrogen ions in excess by doing 10 to the negative, whatever the pH is, because you have a pH less than 7 when hydrogen ions are in excess, and it's the amount that is in excess. So let's type into our calculator 10 to the exponent negative 1.5, and we get a concentration of 0.0, so 3 decimal places, 3 sig figs, 316 ... moles per liter. Okay. Then what we want to find out is how much hydroxide ions was in my original solution, because I know how many hydrogen ions were in my original solution. If I had hydrochloric acid at a concentration of 0.18, that was producing hydrogen ions and chloride ions. So if the concentration of hydrochloric acid was 0.180, then the concentration of hydrogen was also 0.180. So now we're working backwards, and we are going to find the amount that is in, or the amount that was there if it was this much in excess. So what we get to do is we get to say the hydrogen ions in excess are caused because we had more hydrogen ions in my solution than we did hydroxide. Now, we don't have to worry about it being a mixture. So, because it says that the solution contains that concentration, so you can assume that the solution dilution has already happened. So you're allowed to say that I know the amount of hydrogen ions in excess is that 0.0316 ... The amount of hydrogen ions that was in my solution is the 0.180, and then I want to find the concentration of hydroxide. Now, I could have rearranged that formula first, but instead I'm just going to say that the concentration of hydroxide ions is the 0.180 minus the 0.0316, which is going to give me oh no, man, I just cleared my calculator. That's okay. I can do 0.18 minus 10 to the negative 1.5. Always store and recall. So I'm going to get the concentration of hydroxide ions in solution as 0. I can go to 3 decimal places, 148 ... And then they just wanted to know how many moles of the sodium hydroxide. So how many moles of hydroxide are in this solution? Again, the only thing we get to skip is the solution dilution. But if I want to find moles, I would say that the moles of sodium hydroxide is going to equal molarity times volume. So it's going to be that answer 0.148 ... And then I'm going to change that volume to liters, 0.0400. So I'm going to take that answer in my calculator, which is 3 sig figs, multiply it by 0.04, which is also 3 sig figs, and I get 5.94 times 10 to the negative 3 moles of that sodium hydroxide. All right. Now let's do one that has the flip. Let's start with one that has a pH that is greater than 7. So for this one, this is a basic solution, so I'm going to have hydroxide ions in excess. And it's weird that I find this to be the hardest step, but I genuinely do. And I mean, now that I'm looking at it again, I struggled with it when I was doing the work, but now I'm like, oh, okay, so it's really just that one rule. So if it's basic, I need to find the amount of hydroxide ions in solution. Now I need to go from pH to hydroxide ion. So I can do pH to hydrogen concentration to hydroxide, or I could do pH to POH to hydroxide ion, which I'm going to choose to do. So I'm going to say that the POH is going to be 14 minus the 12.750, which is going to give me a POH of 1.250. Maintaining precision. So then I'm going to find the hydroxide ion concentration, and this is going to be the hydroxide ions in excess, because that's what's causing this low pH or this low POH or this high pH. And so to find that, I'm going to do 10 to the negative 1.250, which is going to give me 10 to the negative 1.25. Now I'm going to store this as A before I go any further. So I get 0. Now, because I have 3 decimal places in my POH, I'm going to do 3 sig figs in my concentration. So 0.0562 ... moles per liter. Then I'm going to know that my original concentration of hydrobromic acid was 0.05 moles per liter. So then I know the concentration of hydrogen will be the same. So 0.0150, 0.0150. And again, acids are always a 1-to-1 ratio. So then I know that the original concentration of hydrogen ions in my solution was 0.015. So now I want to find how many hydroxide ions were in solution. So if I know that the hydroxide ions in excess will equal the hydroxide ions in solution minus the hydrogen ions in solution. So if I want to find the concentration of hydroxide, again, it's going to be, or not again, but now, it's going to be the hydroxide ions in excess plus those hydrogen ions. Right? So it neutralized the hydrogen and then it had that much in excess. So I'm going to plug in that answer from the other question, plus that 0.015. That answer that's in my calculator, I'm going to add 0.015, and I get to 4 decimal places, because I'm maintaining precision, 0.0712 ... moles per liter of hydroxide in my solution. Okay, so I had this much in excess, and then this much would have been balanced out with the hydrogen ions that were given by the by the acid. Okay, so then that's how the concentration of my hydroxide ions in solution, but I want to find out the mass of the calcium hydroxide. So from this, I want to find the original concentration of calcium hydroxide. It's in a 1:2 ratio, so I'm actually going to divide that by 2. So I end up with 0.0356 ... moles per liter. Now I want to convert that to grams, because the original question asked me for the mass of calcium hydroxide. So I'm going to take that 0.0356 ... because it's still in my calculator, moles per liter, and convert it to just grams. So I know that 1 mole of calcium hydroxide weighs how much? Well, I'm going to store this in my calculator before I lose it. Then I'm going to figure it out. Well, we already just did this one. So I'm going to say that calcium was 40.08, and then there's 2 of the 16 grams per mole hydrogens, and then 2 of the 1.008 grams per mole gives me a molar mass of 74.096 grams per mole. Now I've gone from moles per liter to grams per liter, and I want just grams. So then I have to multiply by the volume of my solution, which is 500 milliliters, which I will then convert to liters. 4 sig figs. Awesome. So in my calculator, I'm doing 74.096 times, I have that thing as recall A, times 0.5, which gives me to 3 sig figs, 1.32 grams of the calcium hydroxide was added to the solution. Awesome.